Hello everyone, welcome to this video lesson. In this video lesson, we would like to derive an equation for energy stored in a capacitor. We know capacitor is a device which is capable of storing charge, automatically energy. A parallel plate capacitor will typically have two plates. The first plate will store, say, positive charge in general. Second plate actually acts like a dummy plate by inducing a negative charge, so that between them we will be able to store more charge with less potential. We have explained the principle of capacitor. You can please look into that for the sake of even better information on that. Now let us imagine that there is a capacitor of capacity C who has stored, say, charge stored is Q at a potential difference of V volts. We know the relation between them is Q is nothing but equal to CV. We can say Q is nothing but equal to CV. This implies we can say voltage between them is nothing but equal to Q by C. Now this capacitor is there. We would like to store some more charge. Say, to store extra charge dq between the plates of capacitor, we shall do some work. How much is that work done is, we know the definition of potential. Potential is work done in bringing a unit positive charge from infinite distance up to a distance. That implies work done equal to VQ. To bring only dQ, work done is dW. That is V into dQ. That implies work done in storing a charge dQ between the plates who is having a potential difference V. In the place of V, you can write Q by C and dQ. That's a small work. To store the bigger charge, we need to do a bigger work. We have to calculate the work done like this and add all of them to get all that work done. To get all that work done, we shall integrate that equation, this equation. Integral of W equal to dW equal to integral of Q by C dQ. Integral of differentiation of work done is work done 1 by C integral of Q dQ equal to Q square by 2. That implies the work done in storing a charge Q, which is also stored as energy in the capacitor, is Q square divided by 2C. We can express this work done in the other terms other than Q square by 2C. We can express in some another format also. Let me tell you what is that another format is. We know charge per unit area, which is called surface charge density, sigma is Q by A. That implies Q can be expressed as sigma into A. In the place of Q, I can substitute that. That implies energy stored in the capacitor is Q means sigma A whole square by 2. Capacity of a capacitor is epsilon naught A by D. We have derived this equation already so many times. So what happens to my equation? Sigma square A square by 2 epsilon naught A by D. That is sigma square A square into D by 2 epsilon naught into A. 1A can be cancelled. That implies capacity energy can be expressed in the other format like square of charge density into area of the plate into distance between the plates by 2 epsilon naught. This is another way of expressing the capacity of a capacitor. Anyway, there is even other possible ways also. What are that other possible ways? Let us see. We know energy is nothing but equal to Q square by 2C. But we already know that Q equal to CV. Therefore energy will become C square V square by 2C. 1C will get cancelled. So you can express the energy stored in a capacitor even as half CV square. You can express in terms of Q and C. You can express in terms of C and V. You can also express it in terms of Q and V as what? The format of expressing energy is equal to, we have already proved an equation something like half CV square half let us keep the V as it is in the place of C, as Q equal to CV. In the place of C I can write Q by V and then V square. From here C is nothing but equal to Q by V. So energy stored in a capacitor can also be expressed as QV by 2. So these are the different possible expressions of the capacitor's capacity. We can use appropriate relation depending on the given scenario and the problem. Thank you for watching. Keep coming back for more and more video lessons. Thank you.